Thanks for that introduction, Matt. And yeah, this has been quite an adventure over the last week with this first virtual AGI conference. And as a disappointment in a way not to be able to do the event this June in St. Petersburg as we had planned. I mean, we've had a number of amazing Russian participants in the event, even this way, but the prospect of building links between the Russian AGI community more fully and the rest of the global AGI community. I mean, I think we couldn't quite do that as fully as I wanted with this virtual event, and I'm looking forward to doing the other half of the AGI conference event for 2020 in St. Petersburg once travel restrictions ease up. But this part one of AGI 20 online has also been quite amazing in its own way, and I think we've pulled in a lot of fascinating people to the event who might not have been able to travel to the conference otherwise. So I think it's been interesting, and this day, the final day, should be in its own way the most interesting yet, right? So the last couple of days we've gone pretty in depth into the plumbing of various proto-AGI systems and the formal theory of what AGI is, and we've looked at some empirical results from experimenting with proto-AGI systems. And today, the final day of the conference, as has been a tradition in many of the AGI conferences in this series since we started it in 2008 and with the first AGI workshop in 2006. Today we're going to branch out a bit and look at some of the broader implications of artificial general intelligence. And this is a topic that it's a little more speculative than the technical things we've been discussing in the previous part of the conference, but I think it's very important to do this sort of broader thinking in a well-grounded way. And now that AGI is better known and more popular as a concept than it was when we started this series, let alone when I started working on it in the 80s and when others started working on it decades before. I mean, now that AGI is a more popular and better known thing, there's more attention in the media. This has gotten a lot of enthusiasm for thinking about the broader implications of AGI. On the other hand, the way you can think about the broader implications of AGI when you know more about the technical and scientific underpinnings of AGI is a bit different. So we're looking forward today to some grounded discussions of some both near-term topics in terms of how we may build toward AGI concretely and radically and dramatically over the next few years, and slightly further term topics, and what will be the ultimate consequence of building AGIs that can build AGIs that can build AGIs that can build AGIs, and what fundamentally are the nature of non-human minds that we might engineer or whose evolution we might seed. So I'm going to take the next 20 minutes or so and talk about some more speculative and philosophical sorts of ideas that I've been investigating lately, which closely relate to my concrete work on AGI, but they also perhaps have implications beyond the specific systems that I or anyone are working on. So I'm going to talk about some ideas regarding what it might mean to give an AGI system a coherent and benevolent value system. And the whole notion of value systems for AGIs is quite complicated. I'm going to try to unravel a little bit of it, and then I'll talk at the end about what implications this somewhat abstract line of thinking has for some of our concrete AGI work. So can you guys see my shared screen okay? Yes? I'll take that for a yes.
Yes.
Thanks. So
yes,
the The potential risks of advanced AGI have been, they've been talked about in science fiction since before the last century even, and within the science fiction and AI community since the middle of the last century. They were brought to the fore in the public eye in Nick Bostrom's book, Superintelligence, which it's a very well written book. I have some issues with it, and I've published my own review of it online. What I sort of felt Nick, who's a friend of mine and a brilliant man, what I felt Nick did there in part was argue that certain bad things are possible, and then sort of allude that they might actually be probable, while not rigorously trying to argue they're probable. So I mean, he argued that a superhuman mind, it doesn't need to care about humans any more than about rocks. There's no intrinsic reason a human mind needs to have a value system that's aligned with ours in any meaningful way. And there's no guarantee that if we create superhuman minds that they're going to have any affection for us any more than we have affection for amoebas, right? And that's all true. Now, the argument that the AGIs we create are likely to repurpose our molecules into computronium or to not care about us, that argument wasn't made. I mean, the argument he made there was that we don't know, and we can't rule out these dark possibilities, which is fair. And it may be that most human beings on the planet didn't think that way, although if they've seen the Terminator and similar movies, that they probably were familiar with that emotional line of thinking. On the other hand, it leaves open the question of sort of what's likely to happen. Like every time any of us walks out of the house in the morning, there's a small odds we're hit by a car, but we know it's a small odds, and that's different than if it's a large one. And so I want to explore in a little more depth what the different possibilities are and what I think might be more likely to happen, while acknowledging that bad things happening is a greater than zero possibility, as it is for the human race and for each of us without AI. And I also wanted to point out, for those who aren't familiar with his work, I mean, pretty much every key argument in Nick's book was present in the writings of Eliezer Yudkowsky earlier, but woven into a much more complex narrative about the future of intelligence and the nature of the world. And I disagree with a lot of what Eliezer says, but I admire the depth and complexity of thinking. So I just wanted to point out Eliezer's work also to those who might not be aware of it. Now, one of the weaknesses, I think, of Nick Bostrom's line of thinking is a more practical issue, because it's also a weakness of a lot of work in the applied AI world today, which is there's an assumption that what an AI should be doing, how it should be orienting its activities, is toward maximizing expected reward over possible futures. And this assumption is built into a lot of work on reinforcement learning, which has been quite successful and popular. Of course, RL mathematically can be a bit broader than that, but that's the typical way it's done. There's a subtle yet important difference between saying a system should maximize expected reward and saying it should optimize some goal, some function of its future histories, which isn't necessarily a time discounted average of the reward it may get in the future. And this has to do with what's been called the wireheading problem in the hypothetical literature on future AI. Like if the goal of your AI is to maximize the reward it gets over time in the future, well, maybe the easiest thing for the AI to do is to short circuit the circuit that gives it a reward. So it's maximizing reward, and that's sort of what some of the drugs people like to take do, right? They short circuit in a way some of the brain circuitry for delivering reward that was supposed to deliver the reward for other purposes. Now, but if you're maximizing a function of future histories, which isn't a sum of expected rewards, then wireheading isn't so transparently simple, because you could define your function over your future histories to say any future history where I have wireheaded is bad, for example. And, there's nothing flaky or mathematically off about optimizing a goal defined over future histories rather than the sum of expected rewards. It's just the math of reinforcement learning and Q learning and all that works better. I mean, we know how it works with expected rewards, so there's a convenience there. And the math of Marcus Hutter's AXE works well with expected rewards. We sort of know how to tractably work with that, but that doesn't mean it's actually going to be the right thing to do for an AGI system. And of course, optimizing a goal function over future histories is also not the broadest way one conceives an intelligence. And we're going to have a panel today on open-ended intelligence, which is just a philosophically different way of thinking about intelligence. In thinking about open-ended intelligence, optimizing anything is not really what the AGI mind is fundamentally after. It may optimize different things during different stages in its development, but you're looking at an intelligence more as a complex, self-organizing system, which is recognizing patterns in itself and its environment, expanding its boundaries, creating new things, and it may be engaging in repeated acts of radically novel creation that defy any particular objective function you could pin down. One of the points that Eliezer Yudkowsky made for quite some time, which is relevant to the discussion today, is human values are pretty complex and subtle. And, in the mathematical or philosophical picture, the human values are a little bit arbitrary, right? I mean, like we have a love of family, which is important to all of us, right? Including us crazy AI researchers. I've got by now an army of kids and starting on the grandchildren and so forth. On the other hand, the way we care more about our children than about our cousins and about our second cousins or third cousins. And we care, it seems, more about monkeys than about whales or dolphins. Whether we care about eating meat or not is a little confusing. There's a lot of arbitrariness in what humans think is valuable. We definitely think the life of someone starving on the street in front of us is more valuable than the life of someone starving on the street in the Congo somewhere, which we're not worried to do much about unless we're in the Congo in front of them. So the complexity of human values means that you're not going to likely be able to just script a few lines of Python encapsulating what it means to be good in the human context. Human values are a complex and peculiar thing, which have evolved in a particular way due to our history as biological organisms. And what's important to us as people that has profound value to us in our humanity, but it may be viewed as somewhat arbitrary by a superhuman AI system, or even a slightly different mind than us. And of course, you can see this by looking at the variation of value systems over human history, because much of what was viewed as incredibly critical, important in medieval Christianity, we now think is irrelevant, like people's sexual preferences, for example. So I've tried to articulate broad general values that I think can be abstracted from the particular values across human cultures, like joy, growth, choice. And you can try to flesh out things like this, and others have done a more thorough job of it. But in the end, the interpretation of each of these words is quite subtle and not rigorous, and ties in with so many particulars of human mind and human culture that choice is tied up with free will, which may or may not exist in an ontological sense, but exists as a psychological experience that we value, right? And so and by joy, we don't necessarily mean just injecting morphine into the brain and feeling raw pleasure. We mean something richer than that. So even when it seems like they're simple human values, that they're actually quite complex. And you can see this complexity in practice in the AI world. Google, one of the great companies of our time in so many ways, they used to have, as is well known, the corporate motto, "Don't be evil," which got, I believe, got deprioritized or deleted when they refactored their corporate structure to put Alphabet as the top holding company. And I always thought that was a little wimpy, because I mean, if you're building, you know, the world's biggest and smartest information system that sucks in everybody's data and affects everybody's lives and minds in such a profound way, not being evil while maximizing shareholder value is not what I would want to see. What I would want to see is all these resources being deployed in a way that actively does good rather than just not being evil. On the other hand, you know, evil and good are famously poorly defined, and in issues like Google's involvement with China, I'm not even sure what's good or evil. It's not especially obvious, because the Chinese government does things I don't agree with, as does Donald Trump, for example. On the other hand, reaching out to Chinese people and AI researchers is not a bad thing. This ties into a theme I've been working on a lot in the last few years. I mean, Google, as great as it is a centralized corporation controlled by a few people with a prime directive of maximizing shareholder value. And it's not clear that this is the best way to get positive human ethics, whatever they may be, out into the mind of the AGI as we transition from narrow AI to AGI. And in SingularityNET project, we've been working on building an infrastructure that allows multiple AIs to cooperate and collaborate wherever they may be sitting or hosted, whoever may own them or whoever may have written them, without any centralized controller. So it's sort of trying to build the underlying fabric for a distributed, decentralized AI mind rather than a centralized one. And there's an argument that this can lead to a more positive and beneficially oriented AGI system. I mean, there's also an argument that there are risks associated with this, because if you have a centralized system with a good guy at the top, it could in a way be safer than a chaotic decentralized system with all the mess that democratic organizations come with. I mean, I'm placing my bets on the decentralized democratic side, but there are certainly a lot of issues to be thought through here. And so one commonsensical thing you can do, if you're concerned about biasing the odds toward AGIs that are good and beneficial by human standards, understanding the complexity and, you know, in a mathematical sense, arbitrariness of some of our human standards, one thing you can do is just try to make sure that the AGIs or the proto-AGIs, the narrow AGIs that you're creating as you broaden your narrow AI systems to do more and more general things and move toward AGI, you want to make sure these systems are actually doing positive things as they're acting in the world. And this doesn't guarantee anything, but the concept is, if the early stage AGIs are being, you know, elder care workers and teachers and nurses and scientific researchers and combating climate change and so forth, then probably the super AGI they eventually evolve into is going to be more beneficial to humans than if the early stage AGIs are being, you know, advertising salespeople, government spies, controlling killer robots, and doing financial trading to allow large funds to shaft the average investor. So I mean, the idea there is that having our early stage AGIs do things that are qualitatively beneficial may help the later stage AGIs also be more qualitatively beneficial. And I mean, that was the goal behind the loving AI work I did with Hanson Robotics and OpenCog a while ago, where we used the OpenCog AI system to control the Sophia robot, giving meditation guidance to people, doing sort of deep listening and the sort of spiritual psychotherapy of people. And this, you know, these were early stage prototype experiments. I'm showing now a video of one of them, but they were certainly evocative and interesting. And some of the people involved, including the gentleman in this video, really had a quite interesting and profound consciousness experience through these meditation experiments. I mean, as well as that, I'm now engaged in our Singularity Studio enterprise AI company with using machine learning and reasoning in the OpenCog system to help with COVID-19 clinical trials, to help figure out which combinations of antiviral therapies will help to combat COVID-19 in which people based on their genomic data. And I mean, in silico medicine with Alex Javarenkov is doing this as well, and a host of other people. So you can use AI to help with immediate human concerns. And Ibi Benali from SingularityNET team will give a brief talk later today, which will touch on this and touch on some things we're doing using machine learning and signal processing to analyze data about your body from smartphone peripherals like a digital thermometer, pulse oximeter, Fitbit, and so forth, which can help identify an infection a few days before the symptoms show. So there are ways to use AI that are explicitly helpful to people, and having an AI that's explicitly helping people that then gradually verges into an AGI that fully understands what it's doing and why you made it help people. This in no way guarantees this is going to lead to a superhuman AGI mind, which is beneficial to people. On the other hand, there's plenty of qualitative reasons to think that will bias the odds toward positive outcomes rather than developing advanced AI for purely corporate profit or national defense or national offense reasons. So having framed all that, in the last few minutes of my talk here, I want to talk about some recent ideas I've been developing. And this is speculation that's been in my head for a long time. I recently put some blog posts on this in my blog, Multiverse According to Ben. But I want to just throw these ideas out there briefly. So one thing I started thinking about is, what would it mean for a value system to be consistent and coherent? And one interpretation you could look at is, what's good for the whole should be in a way the composition of what's good for the parts. Say if what I valued as best for a family was what I valued as best for the individual parts of the family, then put together into a family, or if what I valued for myself over a long period of time was the composition of what I valued for myself over the short periods of time composing that long period of time, then there's a certain consistency to the value system. And clearly, most of our human implicit value judgments don't fulfill that. Like what we value for ourselves over 10 years is not what we implicitly seem to value for ourselves over each hour. There's some correlation, but they're not identical. And what we value for each person may not compose consistently to what we value for a whole society, which leads to all sorts of problems in everyday life and in politics and in other ways. Now you can formalize using some basic math what it would mean for a value system to be coherent, and you can think about a sort of convergence process. So you can think, if you have a fully coherent, self-consistent, non-contradictory value system, and then you have an incoherent, in some ways self-contradictory value system. I mean, you could say, well, okay, we have an optimization problem. We want to find a value system that's close to the consistent, coherent one, is realizable using the infrastructure we have at hand, and is as close as possible to our incoherent initial condition. And I mean, it's a multi-objective, two-objective optimization problem. You can look at a Pareto frontier for that, and so forth. And it's interesting to think about what that would actually yield. Like what's the fully coherent value system that's closest to current human values? And I mean, you can say that a more universalist human value system is probably a closer approximation. I mean, in terms of time, really valuing in the moment, doing what is best, what you think is best for you in the long term. I mean, this is coherent among short and time intervals, and truly valuing for yourself those actions that you do that you think would be best for society as a whole, this sort of universalism is more coherent than how most of us operate. But this is it's sort of an open question. If you really found a coherent value system that's as close as possible to the current human one, what would it look like? And I mean, of course, adopting that coherent value system, if we were able to do it, would change what we are fundamentally. And this highlights a significant point on which I also differ somewhat from Bostrom and Yudkowsky, which will lead into the final points I want to make here. I mean, when you're architecting a real proto-AGI system, be it OpenCog that I'm involved with or whatever else, I mean, you are often supplying the system with explicit goals, and it could be one objective function it's supposed to optimize or multiple objective functions it's supposed to balance between. But the interpretation of these goals is just part of what the mind does, and you can't differentiate it easily from, at least not in the OpenCog architecture. You can't distinguish the interpretation of the goal that fully from the rest of the mind's cognitive processing. And certainly that's true in human minds. I mean, if you have a goal to to help children, say, I mean, what that means may be very, very different to different people. And as we evolve and develop over our lives, we're constantly reinterpreting our goals and objectives. So there's a subtle problem here, right? Because if the goal is totally separate from the rest of the mind, you get wireheading type problems. But if the goal is interpenetrated with the mind's cognitive understanding in a rich way, then that's fine. But then you have no way of knowing the goal as interpreted by later versions of your AGI system is going to resemble, to you who created the AGI, that goal as interpreted by later versions of the AGI system. And I think that's just what it is. I mean, if you look at minds as open-ended intelligences, I mean, a complex, self-organizing, adaptive system can create and adopt goals and work toward optimizing those goals as part of its complex, adaptive, self-organizing process. But interpreting those goals in context-appropriate ways is part of its cognitive processing. And then, replacing those goals with other ones as it develops is also part of its processing, just as some goals that were highly important to me when I was 18 years old are much less important to me now. And at 53, some goals important to me now will not be important to me at age 70. And that process of goal evolution isn't necessarily well modeled as an optimization process in itself, although it's an intelligent process in a broader sense. And this pertains to one of the higher end and further outlines of thinking about AI goal systems, which is the idea of approximate goal preservation under recursive self-improvement. So imagine you have an AI that has root level access over its own code, which an advanced AI certainly should have. Why should it rely on stupid humans to improve its code when it can do it better? So you have an AGI that can rewrite itself to make it into a better AGI, that can rewrite itself to make it into a better AGI, that can rewrite itself to make it into a better AGI. And of course, if the original AGI has certain goals, part of its goal in rewriting itself will be to make a system that can even better achieve its goals. I mean, almost by definition of what a goal is. On the other hand, this seems like what could possibly go wrong type process, where when the AI makes a smarter AI that's supposed to have the same goals, which then makes a smarter AI that's supposed to have the same goals, can errors creep into the process? So it's a pass the secret type thing. You're dealing with finite resources systems all along. So after 10 or 20 sequences of AI makes AI, makes AI, makes AI, makes AI, makes AI, each getting smarter, well, the original goals have morphed into something totally unrecognizable. So, I mean, none of us knows. I posted a blog post sort of trying to explore this issue in a formal way, and the formalism is very sketchy. So it's more like a mathematical poem than a rigorous proof at this point. But my conclusion was, in a way, this is a bit like convergence of finite iterates to a fractal attractor. I mean, you can start with an AI that builds AI that's supposed to be smarter than it, whose goals capture the spirit of the originals, another AI that's supposed to be smarter than it, whose goals capture the spirit of the original, and so on. Then you have a series of AIs building AIs. And you can formalize this so it looks like you can get, in the right metric, convergence to an attractor. But what's interesting is if you think about it that way, which is extremely speculative, you conclude that for the AGIs further along in the series, they're going to have approximate goal preservation, right? Like by the 1000th iterate or something, maybe that super smart AGI will create another AGI embodying its goals, and the goals of this 101st or 1001st AGI will be about like the goals of the 1000th AGI. But if you're early on in the iteration series, I mean, then the next iterate that you create may look a bit less like you do, which is what the picture at the bottom of the slide is intended to evoke. So it's a very out there line of thinking, but based on my thinking on it so far, I can sort of see why for an advanced AI you might converge on a condition where there's stability of goal system content under recursive self-modification. I don't yet see a strong reason why we'd have that in the early stages. And this gets back to the question of, if you say want to make your AGI's goal system coherent and self-consistent, how much of what makes us human and what we care about is lost when you come up with a coherent value system that somewhat approximates a human value system. And this is for us to explore. And it also ties in with questions like, how much of what made medieval humans was lost in the evolution from medieval humans to us now? Like looking back, we feel like, we've grown beyond what medieval Christian humans wanted, but we're basically the same thing. Some of them might feel like, we're gay, we're taking drugs, we're all going to burn in hell. Like we've lost the fundamentals of their humanity and become demon spawned or something, right? So it could be that the AGIs that we create and the AGIs they create will think they are carrying on the essence of human values, but they may end up missing things that we think are critical from our position. And my preliminary analysis suggests that phenomenon will not be so badly there once you're very far along the sequence of derivatives. But of course, that's not where we are right now. So I mean, this is fun stuff to think about. Of course, it's pretty far off from the concrete issues that we're dealing with in trying to build AGI systems now, but it does have some relationships. I want to talk for my final minute or so about our work with OpenCog and the project we're doing now, building what we're thinking of as a OpenCog 2.0 infrastructure, or branding as true AGI systems. So here, we're building on the OpenCog approach that we've heard a bit about in this conference already, where you have a weighted labeled hypergraph knowledge store with various type systems on this hypergraph embodying multiple memory types like procedural, declarative, sensory, and so forth. You have multiple AI algorithms cooperating in updating this knowledge hypergraph, including neural nets, but also probabilistic programming, probabilistic logic, evolutionary learning. And we're engaged now, myself and our team at SingularityNET and OpenCog, including Matt Eclay, Alexei Potapov, Anton, and Sergei Shyapin, a whole bunch of others who've been involved in this conference, Debbie Duong. We're upgrading this system and radically rebuilding the infrastructure to make it more easy to use, massively scalable, more efficiently integrable with modern neural net and floating point AI frameworks. But another key thing on our minds is meta inference, reflective inference. So Neil Geisweiler, who's been presenting at this event, where he was on a panel and co-authored one of the papers, he's been working on reasoning about reasoning in the OpenCog system. And we want to make this more flexible and easier to do in the next version of OpenCog. And the ability to reason about reasoning that's critical to one approach, which is the approach we're pursuing within the OpenCog project. It's critical to one approach to all this stuff of going from a goal system to a goal system that's, more advanced, but captures the spirit of that goal system, or of having your AI architect a new AGI system even smarter than it, that is carrying on its work, but in ways that are more advanced that it can't even understand. I mean, you can try to formalize these things using logic and type theory, and then to the extent that formalizations of these things are useful, having the AI system that can efficiently manipulate these formalizations is one way to get an AGI system that can, rationally think about the sequence of AGIs that it may spawn through its own modifications to its source code. So I think on the one hand, some of these thoughts are way out there in the future, and there's certainly things that we're not going to fully get to the bottom of theoretically, whether by math or by philosophy. We're going to build, and we're going to see what happens, and there's an irreducible risk and uncertainty associated with all this. On the other hand, one can engineer and architect one's AGI systems in a way that gives them the formal and conceptual tools to understand these sorts of processes like recursive self-improvement of goal systems much more fully than humans can understand them. And this is the path I'm personally embarked upon with OpenCog and SingularityNET project, like build proto-AGI systems that do good things, like help with human health and human psychology and mental well-being. Build AGIs that do good things, roll them out on an infrastructure that's decentralized, so as to ensure there's democratic control going forward, and make sure the AGI system has the cognitive machinery to really think deeply about these subtle issues of value system coherence and value system evolution, perhaps even more deeply than we humans are capable of thinking. So I think that's it. I may have exhausted my allotted time slightly, but I hope I've been able to run through some of the issues regarding AIs and value systems as they appear to someone who's sort of thick in the middle of working on actual proto-AGI R&D. And there's a lot that's unknown and a lot of nuance, but I think our understanding of these issues is improving ongoingly as our understanding of AGI itself improves.
Thank you, Ben. Some interesting discussions were happening in the YouTube channel. There was one question that I think summarized, especially in terms of the focus of today, which is, what about humans? I'm trying to get the actual wording here, but can't find it. But what about humans who use, evil humans who use AGI for their own purposes?
Well, we don't have AGI yet, and at least not in the sense of human level AGI. So right now the problem is there's some cases of evil humans using narrow AI for their own purposes, and I think there are other issues of corporations that are doing evil in their use of AI, even if none of the individuals in the corporation are bad people or evil. Just the organization of a corporation or a nation state as a sort of collective intelligence entity, maybe leveraging AI to do bad things, while each person involved is a good-hearted person trying to fulfill their own life goals. So yeah, I mean, I think if we had to look at, what's the odds of massive death and destruction or annihilation of humanity happening because of AI, the risk of, malevolent modes of social organization leveraging AI in a destructive way is quite clear and quite palpable. Whereas the risk of superhuman AGI is nebulous and hard to estimate. And I think that's certainly a fair point. One of the things we don't know is when we get human level AGI, how quickly will we move from slightly less than human level AGI to significantly greater than human level AGI, right? Because if that's fast, then the problems are basically nasty human organizations using narrow AI for bad means. And technology doesn't have to be intelligent to be destructive, like nuclear weapons or bioweapons. Maybe just adding a little narrow AI to other nasty things can make it even more destructive. And then super AGI, which is superhuman, having the right value system, which is the sort of problem I was talking about. On the other hand, if it's going to be a drawn out transition from slightly infrahuman AGI to superhuman AGI, if that's a drawn out transition, then you have scenarios like science fiction likes to write about, where you have, or movies like to show, where you have humans and like roughly human level AIs and robots, marching down the street and oppressing people or something. Now, my guess is the transition will be relatively fast, so that the question is abuse of narrow AI by nasty human organizations versus what is the value system of the super AGI. But we don't really know how fast that transition will be. That's one among numerous glaring unknowns in all this business.